At first glance, it seems impossible. How could a gas-powered car with 1,000 horsepower possibly outperform an electric vehicle boasting 3,000 horsepower? In today's era of electric hypercars, we're trained to assume that more power automatically equals more speed. Electric vehicles promise instant torque, multi-motor setups, and mind-blowing acceleration numbers that make gas cars feel like relics of the past. Yet, when the rubber meets the road, reality tells a different story. Despite their astronomical power ratings, those electric cars often struggle to translate that energy into usable speed. In this video, we'll watch 7 reasons why a 1,000 horsepower gas car can outperform a 3,000 horsepower EV, revealing the hidden factors that make the impossible possible. Let's watch. 1. Weight, the heavy burden of batteries. Electric vehicles require massive batteries to deliver extreme power and extended range. These batteries often add 1,000 to 2,000 pounds or more compared to gas-powered cars. While electric motors deliver instantaneous torque, the sheer mass of the vehicle can neutralize that advantage. Weight affects nearly every aspect of performance: acceleration, braking, and cornering. A heavy EV struggles to put its power to the pavement, often leading to the slower real-world acceleration despite impressive numbers on paper. Drag racing and high-speed performance are particularly affected, as the vehicle requires more energy to overcome inertia. In contrast, gas-powered cars are usually lighter and better balanced. This allows them to efficiently convert engine power into forward motion without being bogged down by mass. When every fraction of a second counts, the weight difference can determine which vehicle crosses the finish line first. 2. Torque isn't always an advantage. Electric vehicles are famous for their instant torque, which enables them to reach 60 miles per hour in just a few seconds. However, torque without control can be a double-edged sword. When an EV unleashes its full torque, the tires can easily lose traction, leading to wheel spin and wasted energy. Gas engines, on the other hand, build torque progressively. Advanced transmissions and launch control systems help gas cars apply power in a controlled manner, maximizing grip and acceleration. Even a 1,000 horsepower gas car can outperform a 3,000 horsepower EV if it maintains traction where the EV's immense torque overwhelms the tires. Additionally, EVs often have thermal limitations. Running their motors and batteries at full capacity repeatedly can cause overheating, reducing performance mid-run. Gas engines, properly engineered for sustained high-output operation, can maintain peak performance longer, giving them an edge in extended performance scenarios. 3. Aerodynamics, the invisible factor. High-speed performance isn't just about power, it's also about how a car slices through the air. Many EVs are designed primarily for efficiency to maximize range, prioritizing minimal drag rather than high-speed stability. While this improves battery longevity, it can reduce downforce and compromise high-speed handling. Gas supercars, in contrast, are engineered with aerodynamics optimized for performance. Active wings, splitters, and diffusers generate downforce to maintain traction while reducing drag, allowing lighter vehicles to achieve higher effective speeds. Even with lower horsepower, these aerodynamic advantages enable gas cars to outperform heavier EVs on tracks or drag strips. 4. Thermal management and sustained power. Electric vehicles are capable of delivering astonishing bursts of power, allowing them to dominate short sprints in 0 to 60 miles per hour runs. However, sustained high-performance driving presents a major challenge: thermal management. Batteries and electric motors generate significant heat under prolonged high-output conditions, and as temperatures rise, the vehicle automatically reduces power to protect components. This throttling limits performance during extended track sessions, long drag runs, or high-speed highway driving. Gas-powered cars, by contrast, have been engineered over decades for endurance and consistent output. Their engines can operate near peak capacity for long periods without significant performance degradation. Advanced cooling systems and proven mechanical designs allow gas cars to maintain acceleration, speed, and reliability under continuous stress. This distinction explains why a 1,000 horsepower gas car can outperform a 3,000 horsepower electric hypercar in real-world scenarios. 5. Energy density advantage. Another critical factor in the performance debate is an energy density. Gasoline contains far more energy per pound than current lithium-ion batteries, allowing gas-powered cars to sustain high speeds and aggressive acceleration for longer periods without worrying about running out of gas, out of energy. In contrast, electric vehicles must carefully manage output to preserve battery life, especially during extended high-performance driving. Even the most advanced high-performance EVs face limitations in energy storage and thermal management. Batteries are heavy, take up significant space, and store less energy relative to weight than a tank of gasoline. This impacts both short bursts of acceleration and sustained performance, giving gas cars a natural edge in real-world racing and track scenarios. Energy density also plays a key role in weight distribution and balance. Gas-powered vehicles can be lighter and better balanced, which improves handling, braking, and acceleration efficiency. In practice, this means gas cars convert their energy into motion more effectively, often outperforming EVs with much higher horsepower in real-world conditions. 6. Transmission and gear ratios. A common misconception is that electric vehicles, with their single-speed transmissions, are automatically superior in performance. While electric motors can deliver torque across a wide RPM range, single-gear setups can lose efficiency at extreme speeds, limiting acceleration once the motor reaches its peak power threshold. Gas engines, in contrast, benefit from multi-speed transmissions that allow them to stay within their optimal power band across all speeds. By shifting through multiple gears, drivers can extract maximum acceleration throughout the speed range, converting 1,000 horsepower into usable, controllable performance more effectively than a single-speed EV drivetrain. This advantage becomes especially evident on drag strips or high-speed tracks where maintaining acceleration beyond 100 miles per hour is critical. 7. Real-world driving dynamics. Performance isn't just about raw horsepower, it's about control, balance, and drivability. High-powered electric vehicles can deliver mind-blowing acceleration, but managing that power in real-world conditions is often a challenge. Tight corners, low-grip surfaces, and dynamic racing scenarios can expose the limitations of even the most advanced traction control systems. The combination of massive torque and heavy battery weight makes it difficult for drivers to fully exploit an EV's potential without losing control. Gas-powered cars, on the other hand, offer a more predictable power curve and a lighter chassis, making them easier to handle aggressively. Skilled drivers can optimize braking, cornering, and throttle input to maintain consistent speed and performance. So why does a 1,000 horsepower gas-powered car sometimes outperform a 3,000 horsepower electric hypercar? The answer isn't in raw numbers, it's in how power is applied, controlled, and sustained. True performance comes from balancing energy, control, and dynamics, something gas cars still do exceptionally well. Let us know in the comments what you think about the gas beats electric. Why is 1,000 horsepower faster than 3,000 horsepower? And don't forget to like, subscribe, and stay tuned for more captivating content on our YouTube channel.